I want to put up the list of places where 90% of coronavirus infections are happening. Home, workplace, public transit, social gatherings, restaurants. I'm going to leave home out of it because that's person to person. That's if your husband, your wife, your kid has it, you get it from them. But all these other places have something in common, namely, they're largely inside with a bunch of other people. What does that tell you?
So what we're seeing, in places that are doing really great contact tracing and mapping what's happening with the spread of infection, they're seeing that these enclosed spaces with lots of people and poor air circulation leads to the fairly rapid spread of the virus amongst susceptible people. If you end up indoors, which we're going to, in an environment where there seems like there's a lot of people and it just doesn't feel right, they're the situations that you should avoid. Use your feet, find somewhere else that, feels more comfortable for you. So, any, workplace, any environment that is not maintaining, a reasonable number of people, like trying to maintain that social distance, that doesn't have good airflow, where everything is being recirculated. And again, a lot of people, and if it's noisy, that is a spot that I would say, I don't need to be in here, or I don't need to be in here for very long.
That's interesting. If it's noisy, is that because it means that a lot of people are talking loudly and perhaps putting more virus into the air?
Yeah, I was reading some really fun stuff about that. The normal talking releases a certain amount of respiratory droplets, and the louder you talk, the more you release. So I just sort of laughing with my wife the other night, talking about loud talkers and how we have to run away from them now. So, the environment that you get in, the louder it is, the louder you have to talk, which just means there's going to be more in the air if there are infected people around.
Cows, they're just like us. Really, these cows are just like us in one important way, a way that could possibly save lives during the pandemic. These cows have human chromosomes. You've given the cow a human immune system.
Well, we've certainly given the cow a part of a human immune system.
And so this company, SAB Biotherapeutics in South Dakota, is hoping their blood could help make a drug to fight COVID-19. Here's how it works. Using genetic engineering, scientists create a cow embryo that contains parts of human chromosomes. That embryo becomes a calf and then a cow. Then, a non-infectious part of the novel coronavirus is injected into that cow. Because of the genetic engineering, the cow produces human antibodies to the virus. Those antibodies are collected from the cow and, once purified, become a drug that might work to combat the coronavirus in humans. So these cows are plasma donors, just like humans who've recovered from coronavirus and donate blood. But the cows have a big advantage, and that is they're big and have a lot of blood to give.
It's one of the reasons that we chose cattle, because obviously they are a large animal.
Plus, they can donate plasma 3 times a month. Humans can only donate once a month. Another company, Regeneron, is trying a similar approach with mice who are engineered to have portions of a human immune system. The scientists call them magic mice. They extract and clone the best antibodies.
We literally genetically humanized mice. We put in the genes for the human immune system into mice so that these mice have pretty much exactly a human immune system.
Both companies plan to start human clinical trials early this summer. If all goes well, when might this drug be on the market?
So if all goes well, we expect that we will have the drug on the market by early next year.
Of course, there's no telling if this will work, but hopefully these part human animals will play a role in saving lives during the pandemic.
He donated a kidney last summer. Now, A.B. Rohrig is ready to medically volunteer again, this time as a human guinea pig in a vaccine trial designed to infect volunteers with a virus the world has never known.
Just like the nurses and the doctors on the front line, I'm willing to take some risks myself if it means that we can move through this as a nation and as a world.
He's 20 years old, lives in New York, has seen what the pandemic can do, and has signed up online to be a volunteer in a potential COVID-19 human challenge vaccine trial. Unlike other vaccine trials, in a challenge trial, A group of volunteers would first be injected with a potential vaccine, and a second control group would be injected with a placebo. After allowing sufficient time for the volunteers who got the vaccine to hopefully build up immunities, it's all challenged. All the volunteers, those with and those without the vaccine candidate, are intentionally contaminated with coronavirus. Risky, potentially even deadly. Yes, all of that. But it also might be a quicker path to an actual vaccine for the rest of us. This is designed to get some people sick.
That's right. The intention is to make some people at least infected.
Mark Lipsitch, Harvard epidemiologist, is one of the scientists whose idea of using a challenge vaccine for COVID-19 is now gaining interest from the World Health Organization.
This could save months off the time required to evaluate a vaccine. The goal is to do the fastest, responsible, and scientifically valid way of evaluating the vaccine.
Multiple vaccines could be tried at the same time, controls put in place for proper medical care for all the volunteers. And by selecting only young, healthy adults, Lipsitch says the chances of someone dying is extremely low.
But it is not zero, and that's why this is an altruistic act to volunteer for this.
It's not just the risk, it is the unknown risk, says Professor Robert Reed at the University of Southampton in the UK. He's in favor of the idea, but insists there would need to be full disclosure.
This case is different. We're not able to quantify the risk to the volunteer. And when we take informed consent from them, we will have to say to them that we cannot say exactly what is going to happen to them.
You're going to be infected with something for which there is no treatment for at this time.
Right.
Does that give you pause?
It certainly gives me pause, and I don't want to be naive or arrogant, and I don't want to hide myself from the fact that there is a serious, not at all trivial risk to me doing this.
Despite the risk, 16,000 people from more than 100 countries have already signed an online form saying they're interested in becoming volunteers. That includes U.S. Army veteran, businessman, husband, and father of 4, John Gentle of Alabama.
Yes, I am putting more people directly related to me at a greater risk if something were to go wrong, but I feel like the risk is low.
So far, the challenge vaccine trial is hypothetical, but John Gentle, A.B. Rohring, and 16,000 others say they are ready, if needed, to take the risk if it means they can be part of ending the COVID-19 pandemic.
Now I am ready to go out into the ER. Don't know quite what to expect yet.
Don't know what to expect in so many ways. The coronavirus has challenged ER doctors like Matt Bai since it hit, baffling doctors with its mysterious symptoms. Coronavirus is a respiratory virus. It can spread through droplets with each cough or each breath.
You have a droplet that then goes into your nose, maybe down to your throat, and eventually down into your lungs.
But some people have critically low oxygen levels and yet still appear like you and me.
Almost unimaginable how people could be awake and alert and have oxygen levels that are half normal.
And it gets even more confusing. A respiratory virus doesn't typically cause isolated loss of smell or bumps and lesions on the feet. From nose to toes, and nearly every organ in between. How does a microscopic strand of RNA wreak so much and such varied destruction?
So when they come in, they can be to the extreme where they have no pulse already, or they're coming in breathing really fast and hypoxic with a very low oxygen level, and cold and blue.
It could have to do with the way the virus typically enters our cells in the first place. You're looking at the ACE2 receptor. Now see how the spikes on the coronavirus bind to the surface of the cell.
This particular receptor is known to be in lung tissue, but it's also known to be in the heart and other parts of the body. It seems that this ACE2 receptor is expressed more potentially with age.
Higher levels of ACE2 are often present in men, which could also explain why they are most likely to be affected more severely. Patients like 33-year-old Warren L. Vega, who had a life-threatening blood clot in his lungs.
Next thing I know, I was on the floor.
Then there's the mystery of what it's doing to some children. At least 3 dead now in New York from an illness with symptoms similar to Kawasaki disease, a condition where the blood vessels become inflamed.
We have about 100 cases of an inflammatory disease in young children that seems to be created by the COVID virus.
The children that are having these signs of inflammatory conditions, they already had the infection over 2 weeks ago. This is not like another virus that I've seen.
This tiny little virus, which cannot even be killed, because truth is, it's not even alive.